I will talk about Intro to Slurm. And the first is the text big enough? Maybe I should make it larger.
I think it's okay.
It's okay. Okay. So I will talk about the batch scheduler, Slurm, the batch system. And Slurm is the one that's used at, I think, all the Swedish HPC centers actually now. It's an open source job scheduler. It gives 3 key functions. It keeps track of the available system resources, so it knows there are CPUs, GPUs, how much memory, and so on. And it all allocates to the users exclusive or non-exclusive access to said resources for some period of time. And it also enforces the local system resource usage and the job scheduling policies. It provides a framework for starting, executing, and monitoring work. And it manages a job queue, where it distributes the work across these resources according to policies. And those policies vary a little bit among centers, but there is a priority queue, and several of the centers have what Joachim explained also, so that the longer it sits, the more likely it will start. Not all centers do that, like HPC2N, but it is generally the case. Slurm is designed to handle thousands of nodes in a single cluster, and it can handle up to 120,000 jobs per hour. So it's possible to send a lot of jobs. There is no other limits that stops you from, I think, 10,000 jobs or something per user, but I'm not sure. It is also something that is center dependent. You can run the program either by giving all the commands on the command line or by submitting a job script. You should usually use a job script. And the reason for that is that, well, for the first, it doesn't block the screen you typed it on. But of course, it's possible to send to the background or open a different terminal screen. But more importantly, if you use a job script, you will have an easy record of the commands you used. So in the future, when you want to reuse it or make some changes or something, then you can just go look at the job script. So to run a batch job, you need this Slurm submit file. And this submit file, if you look it up on the internet, it will be called many things. Slurm submit file, batch submit file, batch scripts, job scripts. You will have many words for it, but it's all the same. So Slurm commands. There are many more commands than these. These are the more important ones, or at least the more commonly used ones. And you can find more on the Slurm documentation page. So there is salloc, that is for interactive allocation, and interactive is another way of requesting interactive. It depends on the center. Some have either, some have both. Batch, that is how to submit the job to the batch system. So you have the batch script, and then you submit it, as we will see in a moment. SQ is a way of viewing the state of the batch queue. Again, we'll show that in a moment. And then cancel will cancel the job. And control show is to get more info on jobs or nodes. And then there's info for information about partitions and queues. I'm sorry, I have pollen allergy, so. salloc and interactive, I will mention that in the next section about interactive jobs. batch is used to submit the job to the batch system when you have written a batch script, for instance. And you do it by just saying sbatch and then the name of your batch script. And that batch script, you can name it as you want. Convention says that they put the suffix .sbatch or .sh. It's not a requirement. You don't have to use a suffix, or you can use any other. It's just to make it easier to find the script among the other files. So I will usually put .sh because then I can easily find it in a bunch of other files I have in my directory, but it's up to you how you find it easy. Also, one more thing, some clusters have Open On Demand installed. For instance, Alvis and SPC2N. And when that is the case, you don't have to submit the batch job from the command line. You can run it directly through Open On Demand. And in Open On Demand, you actually also allocate resources. So it is actually running a batch job in the background, which you can see, because if you ask for time on the Open On Demand, and then you open a terminal and look, you will see you have a job running. And Open On Demand is good for interactive tasks, graphical applications, visualizations, and simpler job submissions. LUNARC and Tetralit, I believe, also have some, or is it Dardo, have something like Open On Demand. They have the GFX launcher, which is launched from inside of ThinLink, and it works the same way. Regardless, many situations requires you to submit a batch job. It might be that you want to run jobs that need many resources, because there's a limit to how much you can ask for through these Open On Demand for GFX launcher. Maybe lots of memory, lots of time, multiple cores, multiple GPUs, or for a longer time than the 12 hours that I believe is the deadline in those other interactive ones. And maybe you want to run some that are dependent on each other. Again, you need a batch script. And for automation and reproducibility. So. And yes, our clusters, most of them have ThinLink, and you can submit, for instance, MATLAB from within MATLAB as a batch job. All of this is better covered in other courses. So let's talk about the batch scripts themselves for a while. For now, I'm going to use this small batch script here just for testing. And in a little while, I'm going to talk about how what the things inside here do. This script is called simple.sh. And if you downloaded the tarball, and otherwise I'm going to do that now. So it is listed in for the intro page or something, but otherwise the exercises tarball is here, and I'm just copying the link address, and then I am going to create myself a directory to work in that I'm going to call batch. And then I will fetch this tarball. This here, so it looks like this. And it's also up here under the intro. So I'm fetching it. It failed for some reason. No? Oh, okay, it just had a bad connection, but it fetched it. So let's extract the tarball and go into it. And under it here, you find different directories. And since I'm logged into Dardel, I'm going to go to the Dardel directory. Under this, there are different directories, and in this one, I'm going to use the intro Slurm directory. Because in that, I have this simple.sh script. And nano is a module on DOM. Okay, so you see here, this is the same as here. And the only thing I need to do in this case, I need to put in my project ID. And if you're on the course project, you have this one here. Otherwise, you have a different one. Doesn't matter, you put the one you have there. And Nano is a good editor to use if you don't know any specific one that you like. So just say nano, the name of the bash script, which is now simple.sh. Make the changes, hold Control down and push X, save it, exit. We now have this simple.sh, and I am going to submit it. Just to show you what happens. When I submit it, I get this line here, submitted batch job, and then a job ID. And that is what you get when you do this. And then if you want to see if it's running yet, you can say SQ and minus me, or minus you, your username, but minus me is faster to write. It already ran. And you can see it is here. I could use cat or something similar to see what's inside it. It only asked for the host name, and it got that. I could submit this batch job a number of times so that I have opportunity to open it with SQ, and you can see they are already all in the status completing, so it's running fast. And here I have another example, and what you can see here is that you have the job ID. So SQ minus me gives you a list of all the jobs you have running. If you just say SQ, you get all the jobs that are in the queue or running or completing on the whole machine, and that's usually loads and loads of jobs and difficult to find your own. So add SQ minus me. You get a list of your job IDs, which partition they are running in. Right now, they are all running in shared on Dardel, but that is because on Dardel, you tell it what partition you want to run in. You have to. So, but it will list that here. And then the name of the job. If you do not give the job a name, it will just be named your submit script. Again, if you have many jobs, it might help you to find the one you're looking. It lists the user, which would be your name standing here. And then it has a status. And the job can be in many different states. R is running. CG is completing. PD is a common one, it's pending. And it can also be SCF, which is configuring. Maybe you asked for a node which is available but is currently booting, for instance, to change some configurations. They can also be suspended, but that's usually if you if they have been released for other jobs or something. Many different options here. And then time. As soon as it goes to running or completing, it will have a time. Previously, it's always 0, but when it has run some amount of time, it will show how long. This one is completing, It has run for 3 seconds, so it was a very short job. It also tells us how many nodes or CPUs that we asked for. And then a list of nodes if it has started running or has gotten nodes allocated. If it hasn't yet, it tells us why. In this case, it says priority. It means it is sitting in queue. Other jobs have higher priority and are starting to run first. It's waiting. Resources means there is no current free node that has these resources available. It's not necessarily a problem. There may be lots of nodes with these resources, but they are all already filled and allocated. So you just have to wait. And there is some information here on this page. And if you want to try this, go and download the tarball if you haven't already, unpack it, and then run this simple.sh. Or if you don't want to do that, just go here and click copy to clipboard, and then do nano and my script.sh or something, and then paste it here, and then make a change here so you have your project ID. Control down X, and then you would save it. I'm not going to do that because I already had it, but you will save it. Another way of getting this file. And then you try running it. Just submit it a bunch of times and type SQ --me. In fact, it's probably going to run so fast that you should do the SQ --me first. So you have it sitting there in the queue, and then do sbatch your job script a bunch of times. Pushing the arrow up quickly lets you access a previous command. So this way you can probably catch it while it's still in. There are still jobs in the queue and you can see what's happening. Okay, so another thing is maybe you found that you had made an error in your batch script or in the program that you are running. So maybe you will cancel this job if it's still sitting in the queue or if it's running for a long time and you don't want it to spend all the allocation on that. So you cancel the job with scancel and the job ID. Remember, you got the job ID from SQ --me, or you get it when you submit it. You can also cancel all your jobs with scancel -u and your username. Okay, you cannot cancel other people's jobs. Only administrators can do that. scontrols show. That command is used to get more information on jobs and nodes. Remember again, job ID from when you submit it or from SQ --me. scontrols show job, and the job ID gives you a long list of things that you might want to know about your job. Let's try and use it. scontrol show job, and then let's take this. It is available for a little while after a job has run, but as you can see, this was too long. Let's instead start a bunch of jobs again. And now I'm going to grab this one here. And that still has the information. So first, there's the job ID, the job name, some information about who ran it and what group they're in, what priority it had, which account it ran in, and the job state, which here is completed. And it has things like run time, how long did it run? It ran for 1 second. And submit time, when was that? When did you submit it? How long would it have been allowed to run? What was the start time and things like this, the end time, and say all of these things, how long it was allowed to run. Also a list of nodes it ran on and which one was the master, if there were several. Also, how many CPUs did I ask for? And there's also things like if it was a GPU, it would tell what type it was and how many. And this is a CPU, so it doesn't. And then there's a working directory that you submitted the file from, or the job from. And here is the output file, which is in this directory and named Slurm, the minus job ID.out. Jobs output file will, as default, be named Slurm minus the job ID.out. It's possible to name it differently, and it's also possible to split output and errors into two different files. And that will, I believe, be shown in some of the Slurm job script examples. Look at later. So now it is time to do a short exercise. Go ahead and do what I suggested. So you have simple.sh with your course project, with your project in, and then submit it a bunch of times. Try sq minus minus me. Try scontrol show job ID and the job ID you got, and then see some information there. Just test it out. Let's take 3 minutes until 14:11. There is a question from Camille.
Yes, it was about this time, which is written on the right of the job. Is it the time since it started to run, or is it the total time to complete the run?
Submit time is the time I submitted. Start time is the when it stops being pending in the queue and actually starts running.
Yeah, I mean the one when you write SQ.
Here.
Yeah,
time.
exactly. Yeah.
That is the time it has run until now.
Okay.
So until it starts running, if it's pending, as you can see here, it hasn't any started to count any time.
Yeah. Okay.
So yeah, it's how long it has run.
Okay, thanks.
Okay, I will continue. So aside from doing as control show job to see information of a job, you can also use it to get information about a node. And we have a node here, for instance, that we could ask for information about. This control show node this. And here is the node name. And we can see which architecture it is, how many cores there are per socket, and how many CPUs can be allocated, how many there are in total. If something is running on it, and something is, it's using some of it. It's in state of mixed plus planned. That means that there is already something running on it and something is planned to run on it. How much memory does it have? What is the OS on it? Like this. What partitions does it belong to? It belongs to the two partitions on Dardel, which is the main and the shared. It's not a GPU node, so it doesn't belong to any of those. It doesn't have extra memory, so it doesn't belong to an extra memory partition. It belongs to the two regular ones. When was it booted? Or when will it be booted next time? Because it may have an expected time to boot. And things like this. So this can be interesting if you want to check what type of node it is. It might be more common if this place has many different types of CPUs or different types of GPUs and you need a specific. But in any case, it's interesting. S-info gives you information about the partitions and queues. On Dardel in particular, there is a lot of them. And this here is a partition, and it tells us this partition is up and how long it's been and how many nodes are in it. You can see here it lists it once for each of the states. So 3 of them are in maintenance, 2 are draining, 6 are reserved, 51 are allocated, and so on. Reserved could be reserved for a specific course or job, or maybe because something is being tested or maintained. Drained are nodes that are not currently running anything. And it lists which ones are in these states. There is main partition and so many different partitions. And yeah, these are many of the possible states these partitions can be in, or the nodes in these partitions. And you can try and type S-info on your cluster because it will give some info on each of them. So Slurm job scripts. Now we have looked at the commands to control the job, but what about the job scripts themselves? Well, the very simplest possible job script is one like, for instance, what you just looked at. But Dardel and others have different ones because Dardel needs to give a partition. Main, shared, along, on memory, and then GPU. You can see many of these are mentioned here. Usually just pick shared unless you need a CPU. If you need a CPU with less, if you need a number of CPUs less than a full node, pick shared. If you need all the bandwidth of a node, pick main instead. But in any case, regardless of which system, there is something you always have to have here. There is first, notice you see there is a hashtag. The hashtag means it is a command to the batch system. So it should always start with that. And then a capital S batch. It must be in capital letters. You can also use hashtag for comments. If it's a hashtag and not this special case or hashtag S batch, then it assumes it's a comment. If you want to comment out this hashtag S batch, put an extra hashtag in front of it. This line here, the first one, is the shebang. It's a special case. It tells it that it's running in the bash shell. The bash shell is the one that is completely compatible with the batch system. You should always put it there. Then you always tell it which project ID you are running. That is always needed. And this A has to be a capital A. And the project ID is of this form here. When you look at it in super, it's written with a slash and some spaces. It must be written like this instead. Then you say how much time you want. That is usually required. And it is hours, minutes, and seconds. It is generally at most a week you can ask. I think a little bit more on some of the systems. And then how many cores you want. This is a serial job, you just want one core. And then you run your job. Maybe you also need to load modules, then you do that. This is a very simple job. It just echoes the host name. And I went through this here, but there are also different ones. It could be a capital N if you're asking for full nodes. Minus small n, as we have here, is number of tasks. Cores per task is 1 as default, so that means this is the same as number of cores. You can't be sure it's on the same node, at least not on all the systems. If you have a threaded job, or if otherwise, you need them to be on the same node. You should use -C or a combination of capital N and C. C is cores per task. And that changes how many cores each task can use. That can be used for threaded jobs, but it can also just be used to get more memory. Because maybe your job needs more than the amount of memory that a node has per core. Then you say, I want all the memory of 2 cores. And you could do that by saying, I am allocating 4, but I'm only running with 2 cores per task. So this will give you 8 cores. There will be more about this later when we come to job scopes. Time was wall time, P was partition. Not all clusters used it. Data requires it. I mentioned earlier that you can split the output file into output and error, and that you can name them. You do that with -o or -- output equals and whatever name you want it to be. I strongly recommend that you add the environment variable %j into the name that you are using, because that means that each time it runs, the job ID get added to the output name. And that means you get a separate file each time you run it. Otherwise, you risk overwriting the stuff that you just output. And we already talked about the example script. So, and it's also in the exercises table. So you could copy it up there, or you can just get it from the table. Now, a few things about wall time or time. The job will terminate when the time runs out. I know Joachim already mentioned much of this, but the job runs out. When the time runs out, the job terminates, whether it's finished or not. You are only charged for consumed time, so your project is only charged or uses this time that you have actually consumed. So if you ask for 5 hours and it runs for 5 minutes, your project is charged 5 minutes. If you ask for a lot more time than is needed, the job could take longer to start, because short jobs can start quicker due to backfill. There will be small spaces in between longer runs where your job might just fit, and so it will start. If you have no idea how long your job takes, ask for a somewhat long time. Generally overbook your job so you don't risk losing the data by it ending before the job had actually finished. There is a lot of other statements and commands that you could put in the Slurm batch script. Some of those will be covered in the job scripts section, but I am not going to talk about many of them. I'm going to mention one thing, which is dependencies, because maybe you have a workflow of jobs that depend on previous jobs. They have a pipeline, and that is quite common. So maybe you need to process it first before you do something else to it. And you can handle it through Slurm, for instance. If there are many different steps in your pipeline, maybe you want to do it in a different way by using a script or something else. But if it's only a few steps, then you submit the first job as usual, and then you tell Slurm that it should wait until this job here has finished before it starts the next job. That it can do bit S batch -D after OK, colon, and the job ID from this. And then it should start the next job. So it will sit and wait until this one finished. And as you can see here, there are many different commands. And the most usual one is probably this one, that if a previous job finished with a success 0 exit code, then you run the next one. But it's also possible to have, maybe it should rerun something if a job has failed, or something else indeed. I have some examples. That is, I have a small script that generates a matrix, and this that does the matrix multiplication cannot start until the previous one has actually finished, of course. And you can try those if you want to submit with this one here. So it is in dependency, I believe. So you can see there's one here that's called matrixgen.sh. And again, you need to open it because you need to change the project ID. To whatever you have. I have this. Yes. And I also am using this one here. Again, make this change. And what you put here should be your own project ID. So don't put mine unless you are in the course project. So what I would do now is I would say sbatch matrix gen. Like this. And then I would say sbatch minus D after OK. And then this job ID. And then I will take this submit script. And then it's submitted. And it should sit and wait. So the first one was already ran. It had already ran because, well, it took time to do this. But you can try these two. So this will wait until this has finished. You can see one issue with this, which is that you needed to know the job ID, but that is solvable. You could instead write a small script, and I have done that here. And I'm simply doing it by creating a variable for this matrix. So for this one here, that doesn't have dependencies. So it's submitting that and putting that as a variable. And then I'm using this variable here that I get, the output I get from that, to put in as this job ID. And it works. I've tested it. So you can test it as well. And it is also here, append.sh. So if you if you run depend.sh, then it submits these two. Still, you need to first fix the project IDs in those. And I'm going to mention one more time, which is how to monitor jobs. You saw already SQ --me. You can add -- start, because then it will also give you an estimated start time. There's the S control show job ID. At LUNARC and C3SE, you have job info. It's a wrapper around SQ. All of them uses this one here, which gives you a lot of output about jobs. This specific job that has this job ID, it can be used to see, for instance, how much memory it used, but it will be a very wide output. So you may want to pipe it to something like less than -s, so you can scroll it sideways. Job usage is a command at SPC2N that gives you a graphical, a Grafana view of the resources. There are many more things to monitor job and their efficiency, and it's listed here. But now I'm instead going to go to interactive jobs and talk very briefly about those.